name is LGCSE. In partnership with my team, we're delivering you educational content in the comfort of your own home. Our country needs creativity, and there are two forms of creativity. The one that we are born with, and the other one that education sharpens. We have this platform today to make sure we break the fear of getting wrong. Because the one that we are born with, it fades away. Because of societal pressures, we are afraid to get it wrong in front of others in class. Hence, that is why it is important to follow, subscribe, follow our lessons properly, because you can get it wrong up until you get it right in the comfort of your own home, in the comfort of your own hands. That is why we are bringing this platform. COVID has brought the world to a standstill. But fortunately for you, we have this platform that will help bridge that gap. You will still be able to learn at the comfort of your own home. As you stay safe, remembering to sanitize and wear a mask.
Good morning, ladies and gentlemen, boys and girls. This is a show that is going to help you during this COVID pandemic, where we are going to deal with subjects like mathematics, physical science. This physical science include chemistry and physics, as well as geography and biology.
Thank you so much, Nadam Kitim. Yes, let me also greet you at home there. And as you have said, that's very correct. We are here to help you. We shall be dealing with some of those problematic, areas in all those areas that he has mentioned. All right. And at this moment, now that Nadam Kitim has introduced our names, let me also take this opportunity to introduce the team that we are working with. We have LGCSE, we have Brakamu, we have Brastyles, we have Perhaps. They are behind, but they are the ones who are actually making you see us like this. All right. Okay, so let's start. And Nadam Kitimi, you shall join us later.
Yes. But I think for today's lesson, Nade has to do with chemistry.
That's correct, sir.
The atomic structure, that's what we're going to deal with together, as well as bonding. Thank you.
Thank you so much. Thank you so much. Thank you so much, Nadam Kitim. And boys and girls, like he rightly said, we are doing chemistry, and then the first topic we are dealing with is bonding. You are aware that we are doing chemistry for grade 10, 11, and LGCSE, and therefore bonding is the first topic. Bonding is so important because some other time we are going to talk about electrochemistry, electrolysis, which is the opposite of bonding. Therefore, I think it's very important that we understand bonding first. All right. But before I do this bonding, you have to understand a few things about the atom, the atomic structure. And that is the basis of chemistry. As we know that chemistry is all about matter, and then matter, the smallest particle of matter, is taken to be an atom. So that's where we start. I go an atom. All right. An atom cannot be seen. So I'm going to invite your very abstract ability. That is, I want you to imagine things. I want you to imagine that suppose we have something like a marble. The smallest piece, this atom, for us to understand, let's take it to be a simple and a single identity like a marble. And then this is an atom. And then an atom has been, worked upon by so many scientists, but I'm just going to, come towards the end when they felt maybe they have had what can make us understand it much, much better. Because there's a lot that has been done about atoms. And then I want to take it from here, where we talk about its subatomic particles. That means being the smallest particle in atom, as you know, it also has smaller particles which are referred to as subparticles. And then there are many of them, but I'm just going to take 3. And then these 3 I'm going to talk about are the pen. We can simply say these are the pen. The P being for protons or the proton, and then the E for electron, and then the N for neutron. Why do we start here? We start here because when we do bonding, we have to understand bonding is all about electrons. This is where electrons take a leading role as far as that bonding is concerned. And then in physics, grade 11 and beyond, you are also going to talk about protons and the neutrons, which is in the nucleus, the center of an atom. You are going to talk about radioactivity, radiation, and so on and so forth. And to understand that, you should have got this foundation of an atom. All right? So for my part, I am going to focus for now on this one, on the electrons. And then that will then take us to the level of bonding that we are going to talk about. Right. We have got, let me remove this now. We have got the atom. Let's show the structure, the basic structure of an atom. It can be taken as an identity like that. And then we have got the middle part, which is the nucleus. And then we have got these cycles here. And then these cycles of mine represent what you call energy levels. These are known as energy levels. Another word we use is, we call them shells, electron shells. Okay, so we have talked about those 3 particles in an atom, and then we have to know 3 things about them. You have to know their locality, where are they localized, and then as I've said, the neutrons and the protons are here in the center, known as a nucleus. And then around the nucleus, we have got the shells that have electrons inside them. Secondly, you have to know their relative charges. You also have to know their relative masses. We are coming to that later. And then, now that we have this, we all know from grade 8, if the grade 8s are here, let me hammer this once again, that the electron shells or the energy levels have got a certain number. Each of them has got a certain number of electrons to be contained. As you know, the first one, we call it the innermost shell. The innermost shell is this shell closest to the nucleus. It has a maximum capacity of 2 electrons. That means we can, if we use crosses like that, sometimes they use dots, but for now let me use crosses. That means we have got 1 electron here and then 2 electrons like this. This atom would be, the shell, the energy level is full. Then we come to the next one and the next one and the next one, depending on the number of electrons an atom has. And then I know for your syllabus, we are doing, for LGCSE, we take the first 20 elements, meaning we go all the way to 20. So it means we shall have 2 here, and then the next one, let's take for instance the last atom or the last element we are taking, which is calcium. Calcium will be mass number 40 and then electronic number 20. I'm preparing you for bonding, don't forget that. And then we know that like this, we have got, out of that 20, we have taken 2, so 18 are remaining. And then the 18 that remain will fit into this other shell, and then this other one. Sorry, let me clear this so that it will be clear to you. Okay, we have the nucleus, the first shell, the second shell, the third shell, and the fourth. All right, we have said the first one out of that 20, that is the first shell, will have a maximum of 2, so we have 18 left. Out of that 18, other shells may contain a maximum of 8. Okay, so that means we have got 2, then we have 8, and that is 10. We are left with another 10. Then we take the 10 from there. We shall have 1, 2, 3, 4, 5, 6, 7, and 8. That means we have got another 8 there. Then this is we are left with 2 here, because that's a 16 plus 2, that's an 18. Out of that 20, then we are left with 1, 2, like that. All right, so we say the electronic configuration of this is 2, 8. Let me make this one clearer. 2, 8, 8, 2. Let's take another atom so that we fully understand what we mean by this bonding. Suppose we have another atom, chlorine, with 35.5 as the mass number, and then we have got 17 electrons. Then this one will have the first thing that we should always show is the nucleus, and then we have got the first shell. Let me use dots in this case. We have got 1, 2 electrons in the innermost shell. Then we have got the second one, because we have taken 2 out of that, so we are left with 15. Out of the 15, we have got 1, 2, 3, 4, then 5, 6, 7, 8. And then this 8, out of 17, we have 7 left. The 2 and the 8 giving us a 2,8. Then we shall have the last shell to contain 1, 2, 3, 4, 5, 6, and 7. So the electronic configuration of chlorine is a 2, 8, 7. Then that one of calcium is a 2, 8, 8, 2. Then there's something that we need to know, or you already know that for these shells to be like this, we say they are unstable. They are not okay. They are not satisfied. All right? What we mean? We mean that in order for them to be stable, they have to be full. Being full means for the first shell it's 2 electrons, and then for the other shells it's 8. Therefore, this is where bonding comes in. Bonding is when the atoms involve electrons in order to be stable. Okay, what we mean by that? We mean that this one has to lose or gain 6 or lose 2. Then it will be up to you, to decide which one is better. The options we have here, I repeat, either you gain 6 or you lose 2. Here, either you lose 7 or you gain 1. And then that way the atoms are going to be stable. Therefore, bonding is when these atoms, it's like they come together and they discuss, how do we become stable? It's no problem losing these 2, because the final or the last shell will still have an 8, which we are saying that way atoms are stable. Here it's also possible to lose this 7 and have that as an 8, being the last one, no problem. Or you can add 1 more there to have 8, or you can add 6 more there so that you have the 8. So it's up to you. Now, suppose we take this 2 together, and then we want them to bond together, then no problem, we're going to take them as examples. Or in some other instances, you may have this type together with the same type, or sometimes we have this type together with the same type. In other words, I'm trying to say there are 3 ways, or there are 3 types of bonding that we should know. Let me write them down here. We have the first type of bonding, which is between metal plus non-metal. And then we call this type of bonding let me use a different color this side. Let me remove these atoms for now. We are coming back to them later. We have got the bonding that happens between a metal and a non-metal. Boys and girls, we all know that metals occupy the left-hand side of the periodic table, and then the non-metals occupy mostly the right-hand side of the periodic table. So if these two meet, we have one type of a bonding which we call ionic bonding. Okay? Sometimes known as electrovalent. Electrovalent, we come to those words later. And then there are also instances where a metal and a metal bond. Okay, this is within a metal bar. For instance, you look at a bar of iron, and then the bar of iron is made up of metal atoms together with other metal atoms, and then we call this metallic bonding. Okay, so metallic bond or metallic bonding is responsible for most of the metallic characters we see in metals. We shall come back to that later. And then lastly, we may have a non-metal plus another non-metal. And then in this case, we are talking about covalent bonding. So this is covalent bonding. As I said, there are these three types of bonding: metallic bonding, ionic bonding, and covalent bonding. However, it's much easier to start with this one and then come to this one, and then this one we shall do it lastly. That will help a lot. Okay, so let's prepare, and then we go for metal plus non-metal. That is ionic bonding. Okay, let's go there. We go to metals and non-metals. Let me use this part of the board here, and then the atoms that I drew here, I am going to use them. And to make things faster, this time around I'm not going to draw all the atoms. I'm just going to draw the outermost shell. In other words, the calcium that we had, I'm just going to show it this way, and then I show its electrons like that. That calcium has got an electronic configuration of 2882. I'm only showing the outermost shell for simplicity. And then we come to this side. We have got chlorine. It has got 1, 2, 3, 4, 5, 6, 7, as we said. So it has got an electronic configuration of 287. All right. So I said we decide. You can decide which one is simpler. Is it simpler to add 6 or to lose 2? Okay, I'm sure you understand it's much easier to lose 2 than to try and gain 6. In this case, is it easier to gain 1 or lose 7? I'm sure you understand it's much better to gain 1 instead of trying to lose 7. Therefore, we can decide that this atom is going to lose 2 electrons to this one, meaning this one is going to gain. Therefore, what we are saying is we show this. Be careful here. Don't. Most of you will show the transfer of this electron to this atom, and then they show that it's already there. They show. I'm trying to say at the same time they show us that they transfer, and the electron is already there. It's wrong. What I'm trying to say is that you just step number 1 is to show us that there's going to be a transfer like that one, and then you stop there, and then you decide that out of the 2, one has been transferred here. So that means more or less I cancel this 2, and then I put a 1 there. That means 1 is remaining because 2 has, out of 2, 1 has been transferred already. Then we said this is still not okay, because the last shell should have a maximum of 8 in this case. Therefore, this atom is not yet stable. Then what should happen? It simply means this one cannot gain more than 2. So that one that it gains is fine. Therefore, the best option is to get a similar atom of the same type. Throw it there. There will be plenty of them. Remember, an element is made up of many atoms. And in this case, If we have got another chlorine like that, it means this one can then be lost, and therefore we no more have this. So our new electronic configuration is a 2-8-8 like that, which is okay. And then in this case, each of them, as we see, will have our 2-8-8, no more the 2-8-7. However, this is not good. That's why I put it in bracket. I remove it because we have not come to that stage. This is a stage where we are showing the transfer. We come to the next stage where now we show you the results of that transfer. And this is where now we show the calcium without any of those two electrons which were there in the outermost shell. And therefore it qualifies to bear this electronic configuration of 2-8-8 because there are no more two electrons that used to be there. And then for each of the chlorine, I'm saying each because there were two of them. And then each of the chlorines will have 1, 2, 3, 4, 5, 6, 7, and then 8 with a cross to show that it came from there. And then the same thing happens to this one. And then we have our other cross there. Then they qualify to have this electronic configuration of 2-8-8. But now we have this word. This word comes from what we said, or what you know are called ions. What is an ion? An ion is an atom, this time around, with either excess of electrons or shortage of electrons. Excess of electrons, remember when it was an atom, my left hand is for electrons and then my right hand is for protons. At the beginning they had equal number, so the one that has gained will have excess of electrons, therefore it will have a negative charge. By how much? By 1. We shall have negative charge by 1, meaning there is an excess of 1 electron compared to what used to be there. And then this one remains the same. Nothing happened to the protons, remember? So there are two possibilities. Either there is an excess of electrons or shortage. And then which one will run short of electrons? The one that has lost. It has lost 2, therefore it will have a positive 2 charge, meaning the positives are more than the negatives by 2. Because 2 of those negatives are lost. Here the negatives are more than the positives by 1 because the negatives were gained. Therefore we call this one a cation, a positive ion, and this one an anion. No wonder we have this name here of that type of bonding. It's derived, that name is derived from the presence of protons now, and this ones. And then let's stop here for now, and then think about this. Think about other types of bonds, other types of atoms when they bond. That is ionic bonding. Thank you so much for now. All right, now exercise or exercises show the bonding between the following atoms. 1, let's see, sodium 2311 and oxygen 16:8. Show me the bonding between these two. Remember, you have to break this one first into the electronic configuration so that you can decide whether you need to lose or gain. The same thing applies to that one. Okay, the second one is magnesium 2412 and the same oxygen 16:8. And then lastly aluminium, that's a 2713, and oxygen. Deliberately I'm keeping this one the same, and then I'm varying this one. You are aware this is group 1, group 2, group 3, and then later I shall take different groups and then swap them, but I kept this one as the same group 16 or group 6 so that we understand and see how we have to decide on which ones to lose and which ones to gain. And therefore from here I'm also going to talk go deeper, talk about the formula of compounds from this ionic bonding. Thank you so much. All right.
Parents, let's do more for our children. We have started. We challenge you to partner. Make sure the kids follow for a better Lesotho. Remember, it is important to get the updates every time we have a program. When you subscribe, you will always get the fresh updates of our programming, and do pose your questions. We guarantee you they will be answered.